Alright, welcome to this video. This is lesson 5 of our unit number 7, rational functions, and we're going to be talking about multiplying and dividing rational expressions. In this lesson, we will cover our objective and guiding question. We're going to talk about how to solve quadratic equations where a does not equal 1. I'm going to go over the steps to solving rational expressions when you're multiplying or dividing, do some practice problems, and I'll leave you off with IXL work to do on your own. Our objective: scholars will be able to multiply and divide rational expressions, and the big idea is rational functions. Our guiding question: when we multiply and divide fractions, we can often simplify by canceling out the greatest common factor. So how does this play out with rational functions? For example, 4 over 5 times 15 over 12. Well, that becomes 4 times 15 over 5 times 12, because you multiply straight across. Well, remember that 15 is really just 5 times 3. So that's 4 times 5 times 3. And then 12 is really 4 times 3. So you've got 5 times 4 times 3. Well, notice that these 4's are going to cancel, 5's are going to cancel, and the 3's, and your result is just 1. So how does this play out with rational functions? We're going to talk about that. Before we dive into the material for this lesson, we need to discuss how to simplify quadratics when a does not equal 1. So that's whenever this first number in the front is not a 1. So let's try this example here. Remember my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2 times a. A here is going to be 12, b is going to be 5, c is going to be negative 2. Let's plug into our formula, negative 5 plus or minus square root of 5 squared minus 4 times 12 times 2, negative 2, all over 2 times 12. Simplify this, you're going to get negative 5 plus or minus 11 over 24. That's going to give you two fractions, negative 16 over 24 and positive 6 over 24. So these will simplify. The one on the left is going to be negative 2 over 3, and the other one on the right is going to be 1 over 4. So now let's write these together in the solution form, and it'll look like this. Remember that you got to write the opposite sign. And we get that. But notice that if I was to FOIL this out, I would not get my original. Now the solutions are the same, so I did it correctly, I didn't mess up. But because my a is not equal to 1, if I want it to FOIL and look exactly like this one, I have to do one extra step. So I'm going to notice that this number here is 3 is in the denominator, and this number here, 4, is in the denominator. I'm going to move that in front of the x. In other words, I'm multiplying this whole expression by 4 and this whole expression by 3. So I'm going to get 3x plus 2 and 4x minus 1. So notice I just took the denominator and I just moved it in front of the x. This again is an equivalent expression, but now if I FOIL it, it's going to look just like my original. So we're going to need to know this whenever we're multiplying and dividing rational expressions. So here are the steps we're going to use to solve these equations. Step 1, we're going to combine the two expressions, so either it's going to be multiplying or dividing. Step 2, we're going to simplify, including quadratics. If we have to, we're going to do that whole process where we use a quadratic formula to simplify. And then lastly, we're going to cancel out as many terms as we can. However, there's 3 possible cases. Case 1, only monomials cancel, which is just a number by itself, or just an x squared or an x by itself. Polynomials cancel, so we have a whole expression that cancels, or nothing cancels at all. So those are the 3 possible cases. All right, let's get started. All right, let's try this first example. Step 1, combine the two expressions. I've got multiplication here, so this expression is going to combine with the numerator, 6pq and 6q. So I get 6q, 6pq on the top, and on the bottom, 17p squared, q squared. Now, step 2, simplify including quadratics. Don't have quadratics here, but I am going to simplify a little bit. So I'm going to change this 6q, 6pq, and on the bottom, I'm going to change that to 17p times q times q. All right, now step 3, I'm going to cancel. So I'm going to cancel this q with this q. this q with this one, this p with this one, and I can't do anything else. So then I'm left with 6 times 6 on the top, which is 36, and 17p on the bottom, and that is my final answer here. Okay, now we're doing division. So in division, rather than combining the numerator and the expression, I'm going to combine it with the denominator. So now I'm going to have 7, and then the bottom, I'm going to have 21w plus 7 times 4w cubed minus w squared. Okay, do not FOIL this, because if I FOIL it, it's only going to get more complicated and I can't cancel things. So I'm going to jump to step 2. Simplify including quadratics. So notice here that this can be simplified and this can be simplified. On this first one, 21w and 7 share 7 because 21 is divisible by 7. On the second one, 4w cubed and w squared both share a w squared. So I'm going to pull both of those things out. So I get 7, and then what am I left with? 3w plus 1. And then over here I'm going to pull out a w squared, and I'm left with 4w minus 1. Now I can jump to step 3, cancel terms. I got a 7 on top, 7 over here. That's going to take me to 1 on the top. Remember, it's never going to be 0. If you cancel something on the top and you're left with nothing, it's a 1. And then I'm just going to write everything else on the bottom. 3w plus 1, w squared, 4w minus 1. All right, let's try this one, multiplication. So I've got a quadratic here, which means I'm going to have to simplify this quadratic in a second. 8p squared minus 10p plus 3, all that over 2p minus 1. So I'd like a nice cancellation. We'll see what happens. So let's simplify this quadratic. So I'm going to do negative b, which would be 10, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is going to simplify to 10 plus or minus 2 over 16, which is going to give me 10 plus 2 is going to be 12 over 16. 10 minus 2 is going to be 8 over 16. This is going to simplify to 3 over 4 and 1/2. Okay, now I need to rewrite it, but remember, I would write this, but like we talked about in the beginning, sorry, that's supposed to be a minus sign. We're going to have to change this to look like the original when you FOIL out. So I'm going to take this denominator here, and I'm going to push it to the front of each of those x's, and you get 4x minus 3 and 2x minus 1. Sorry, we're not dealing with x, it's actually p. So this simplifies to 5p minus 2, and then 4p minus 3, and 2p minus 1, all that over 2p minus 1. And look at that, we got a great cancellation. So this and this will cancel, and we are left with just those two top terms, 5p minus 2 and 4p minus 3. All right, let's try this one. We got a lot of things to simplify here, but we can do it. Here we go. 3g cubed minus 2g squared times 3g minus 4, all that over 3g minus 4 times 3g to the 4th minus 8g to cubed plus 4g squared. Okay, so of this first expression here, I'm going to pull out a g squared. This one and this one are going to cancel right away. Right here, all of them have a g squared in common, so I'm going to pull that out too. So I can simplify a little bit. I'm going to get g squared times 3g minus 2 on the top. Remember, those other terms canceled. And here I'm going to get g squared times 3g squared minus 8g plus 4. All right, I've already got another cancellation, and I'm hoping I can cancel again, but I'm going to need to simplify this quadratic. So let's do it again. I'm going to do it over here. Negative b, so 8 plus or minus the square root, 8 squared, which is 64, minus 4 times a, 4 times 3, times c, all that over 2 times 3. All right, this is going to simplify to 8 plus or minus 4 over 6, which becomes 8 plus 4 is going to give me 12 over 6, and 8 minus 4 is going to be 4 over 6. So that's going to give me 2 and 2/3. So then that's g minus 2 and g minus 2/3. But remember, with the fraction, I'm going to take this denominator and push it in front of that g. And so you get g minus 2 and 3g minus 2. Look at that. We're going to get another cancellation. So I can rewrite this. 3g minus 2 all over g minus 2 times 3g minus 2. We get a cancellation, and we're left with just this, 1 over g minus 2. All right, last question. Now this one looks totally ridiculous because it is. I don't even know why they put these questions on here, but they do, so we're going to solve it. You'll notice you've got a fraction within a fraction. Let's start by rewriting this. What we've really got here is 36u minus 18 over the first one, u squared minus 4u plus 1, divided by the second one, u minus 3, and then 4u squared minus 4u plus 1. Okay, this is division, which actually means this is going to go to the denominator and this is going to go to the numerator. So I'm going to get 36u minus 18 times 4u squared minus 4u plus 1, all that over 4u squared minus 4u plus 1 times u minus 3. Okay, we got a cancellation. This and this match, so those cancel. And let's deal with 36u minus 18. We can pull out an 18 from both of those, and we'll be left with 18 times 2u minus 1, and all that over u minus 3. You would like to cancel that, but actually you can't do any more canceling. This is your final answer. All right, that was it. Here's the IXL for y'all to do. Algebra 2 in 5. Please be sure to send me an email or join me during my office hours on Zoom if you have any questions. Best of luck.